Welcome back to another video. This is Codeforces Round 915 due to we're gonna solve the fourth problem, that is cyclic mix. So the problem is very simple, solution is only hard. So let's see what the problem states. We will be given an array A. We have to define its cost as summation of 1 to n mex of a1 a2 up till aa. So how do we write the summation is 1 to n means it is a1 plus a2 sorry a1 plus a1 comma a2 plus until a1 a2 up till an. This is not a normal sum. They are asking the mix of all of this, that is mix of a1, mix of a1 a2 and mix of a1 till an. We are defining its cost, so this is the cost of this. We are given a permutation P of the set 0 to n minus 1. N elements will be there, 0 to n minus 1 numbers will be there. We have to find the maximum cost across all the cyclic shift of P. So cyclic shift we already know, right? 1, 2, 3, 4, 5 means if I want to do cyclic shift means I can bring the right element to the left side. So this is what cyclic shift means. And permutation means it's just an arrangement of numbers. Now, so let's consider a simple example like 0, 1, 2, 3 is here. What will be the max value? The max will be, let's make it even more smaller. I'll do that max of 0 plus, max of 0, 1 plus, max of 0, 1, 2. We will get one answer, okay. What does max represent? It is the smallest non-negative number that is in the array. That means for 0, what is the smallest non-negative number? It is 1. For 0, 1, what is the smallest non-negative number? 2. For 0, 2, 0, 1, 2, what is the smallest non-negative number that is already there in the array? That is 3. And also for information like 0, 3, what is the smallest non-negative number of here? 1. Similarly for 2, 3, smallest non-negative number is 0. So that's what mix is all about. We got this. Now if we do a cyclic shift, we'll get like 2, 0, 1, right? So we have to do mix of 0 plus mix of 2 plus mix of 2, 0 plus mix of 2, 0, 1. We will get some answer. We have to find out of all the possible cyclic shift and compute mix for each of them, what will be the maximum value, maximum cost that is possible. That's what they are asking. So like I guess the question is clear. Let's try to understand this with the help of an example that they gave in the solution in the test case. Then I guess it will be a bit more clear, I guess. So let's see, 5, 4, 3, 2, 1, 0. So what did they say? 5, 4, 3, 2, 1, 0 they gave here. How do we find the max? The max of 5 is what? It is 0. 5, 4 is what? It is again 0. 5, 4, 3, smallest non-negative integer is 0. This is also 0. Max of all of this is 0. But last, max of all of this is what? It is 6. 6 is the smallest non-negative integer. We can't do it. Now I do that. Let's do one cyclic shift. Let's go 0. We can put it here, right? 5, 4, 3, 2, 1. Again, we'll do the max. So 0's max is 1. This is 1. This is 1. This is 1. This is 1. And this is 6. So how much we got? 6, 7, 8, 9, 10, 11. So probably this is also not getting. So we see the solution first and try to derive it. 2, 1, 0. So what did they do? This also gone, right? These two, 1 also gone. Then 2 also this cyclic shifted. 5, 4, 3, 2. Now we'll find the max value of 2. That is 0, 0. This is 1. Sorry, 2, 1, 0. The max value is what? 3. 2, 1, 0, 5. The max value is 3. 2, 1, 0, 4. Smallest non-negative integer is 3. 2, 1, 0, 5, 4, 3. This is how much? Here it's an extra number. This is 6. So the answer is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 is the answer. So we got the cost value as 15. Maximum sum occurs when we cyclic shift it 1, 2, 3 times. If we cyclic shift, we will get the value. Now plain brute force, we can find the max of summation of all, then do one element summation of all, like that we can do and find the maximum value of it. But if we do that, unfortunately it's a D problem also, and they will give us TLE and wrong answer. So that is not possible. So the only thing is we need to optimize this solution in such a way that the answer we need to get it in big of n. So we'll see the constraints also. The constraints, they told that it is 10 power 6. So probably n square will definitely won't work. But what do I think? Ideally speaking, I can say that here I observed that 0, whenever right side it is 0, if I take individual numbers, the max value always will be 0 only, right? So what do? I think like, okay, let's keep the 0 here. Let's rotate the array such that 0 comes here and find the max value so that the number will be maximum. But what happened here is, even though I'm not getting 0 here, everything got to be some other number and we got a value. Even though zeros came here, since 0 is on the right and there are no non-negative integers, smallest non-negative integer, here we got 3, which is a much more bigger value. So here we got it as 15. So ideally we can't correlate anything. 0 keeping at first also doesn't matter here. So there is no correlation that is happening. So we need to think even more. So we'll find out with this with the help of another big example that is written in the question. So this example is the third one that is present here. That is this one, 23670,145. So I traced out all the max value of all the combination. I rotated it once, 5 came here, 4 came here, 0 came here, and 1 came here, then 0 came here, 7, everything, every possible combination I wrote. Again, if 3 goes here also, you can just try out, okay? Now, I just noticed one thing when I observed the last value, right? If I take the entire array, this 8 is static. That is, for an array of 0 to n minus 1, the max value will always be n. If all the numbers from 0 to n minus 1 are present, the max value is n. So that is one observation we found out. And we also told that keeping 0 on the left also might not work. But here what happened? Keeping 0 on the left only gave me the highest result. We also, one more observation that we did. What is that? We understood that keeping 0 here, the left side of every number, since 0 is the smallest number possible, the left side of all the numbers will be 0. Okay, so that is one thing. Now, let's go back to the example that we wrote here and try to take the 0 only for easier computation. Okay. Now, how do we do? In this case, one thing is pretty clear. I cannot go for a n square solution because TLE will come. I assume that if I keep the last number as 0, every number on the left will be 0 only, right? Because 0 is the smallest non-negative integer, so 0 will come. Again, now if I keep on the first, 0 cannot come. There will be some variation that will happen. So what do? Before 0, I know that all the zeros can come, everything will be 0, so let's not put it. So what do? I write it as max sum. So I will mark it as max sum here, okay? So ms is marked as max sum, so I say that max sum of 0, I initially put as 0. Hypothetically speaking, whatever number it's on the left side of 0, it is 0. Now, I know that any number that comes on the right that is greater than the existing number, that is smaller than the existing number, that also can be a possible candidate. See, in this case, 1 came here, so 1 is part of this. So 5 came here, so 0, 1, 4, 5. If we take all these arrays 0, 1, 4, 5, 2, and I consider 0, 1, 4, 5 only, 2 is the ideal candidate, right? It is the smallest number because bigger number won't have any value. This 2 can destroy all the bigger numbers and the first occurrence of a smaller number less than 2. That's how 2 came. 2 has the ability to destroy all the bigger numbers on the left side, stating that I am the smallest number. Before 1, he is the smallest number, like that. So initially I kept a max sum of 0 is 0. Now let's go for max sum of 1. So max sum of 1 is what? I can just say that before 0 everything is done. The smallest number is this 0 only. There are no big numbers. If 100 comes here, 1 will be part of this 100. But no, for this 0 alone, the next possible number, if I take this 0 alone, the smallest non-negative number is 1. So I take like 1 as part of this plus max sum of 0. That is 1 plus 0, that is 1. Let's go for the next number, that is ms of 4. 4 also. my previous guys have already computed it. I am a very big number, so I can't reduce the max value. So what do? I can just keep for this guy alone 0 1 4 0 1. If we consider 0 1 only, the 4 value will come. So I can just say that the 4 value plus max sum of 1, the previous value. So you can write like 4 plus 1, that is 5. Similarly, I can write for ms of 5. Again, for 5 can never be a max before me. So I can write like 5 plus, why am I writing 5? For 0 1 4, if I consider, for this array 0 1 4 5 can come, right? Plus max sum of 4. So as you saw in the definition, max is the smallest non-negative integer x such that x does not occur among b1 b2 up till bm. It's not like 0 1 2 and suppose 0 1 2 is there. Max sum I can't directly say as 3 because I already know that if phi is there here in b1 b2 up till bm, if I say that 0 1 2 find the max means phi is the smallest non-negative integer that is not in the 0 1 2 array. So I say that max of 0 1 2 is 5. Here in this case it is 5 plus max sum of this. So 5 plus max sum of 4 is what? 5. It is 10. Now comes the spiciest part. Max sum of 2. Here if you see, 5 is much bigger value than 2. 4 is also much bigger than value of 2. 1 is the immediate value that is less than 2, right? So what do? I just want to track the 1 because I am pretty sure that if 2 is here, 1 is already part of that. So 1 cannot be part of 4 and 5, right? In the max. So max will be the next value that is occurring. So 2 can come to 0 1 4 5, 2 can come to 0 1 4. For 0 1 also 2 can come. For 0, 1 has already taken care. So what do? 2 occurs 3 times here. So for any bigger number, 2 has the ability to shoot this number, to kill this 4 also. But if it is just a negative number, you just consider it because 0 1. So what do? I have 3 occurrence here. That is 3 into 2. 2 plus 2 plus 2, that is 3 into 2 plus max sum of 5. So 6 plus, I made a mistake, right? It is not 5 here because I removed 5, I removed 4 and only 1 remains. So it is max sum of 1. So max sum of 1 is what? It is 1. That is 7. For 2 we are getting 6 plus 1 as 7 because 5 is already removed. 5 can never be a part. So 4 also can never be a part. 2 is the only game here. For 2 also I assigned a max, 4 also assigned a max, 1 also assigned a max. Max sum of 1 means before 1 what is my max sum? That is also done. Now max sum of 3. How much can I get? Since 2 is a lesser number, whoever is going behind 2 on the left side of 2 will be the answer. So max sum of 2 always exists. 3 plus max sum of 2 because 0 1 4 5 2, the max sum will be 3 plus before 2 max sum of 2 only. So what is that? That is 3 plus 7, that is 10. Okay, I'm missing one thing here. Just note down like what is happening here. Before only we are doing it. So I already noted this statement, right? Max equal to n, 0 to n minus 1. I'll come to that, but let's finish this. So we did for 3 and let's go for 6. It will be, now what? 3 is already smallest. Whoever comes before 6 can never be a max of that. So till 0 to 3 it is 6 plus max sum of 3. That is how much? It is 16. Now max sum of 7. Similarly 0 to 6 the max sum will be less than that. 0 to 6 the max sum is 7 plus whoever is behind 6, it is a max sum of 6 only because 7 can never be going behind, right? So 7 plus max sum of 6 is what? It is 16. 16 plus 7 is how much? It is 23. But in the answer we got as 31 for 7. Why? It is because we are considering the number 0 to 6 only. We are not considering the number 7 because we already know that this number is a static number 8. So if I want to compute for 0 1, I can simply put 1 plus 8, 5 plus 8, any number. If I want to know the maximum, I can just put 7 plus 8, 10 plus 8 and 16 plus 8 and 23 plus 8. So for this 7 is the ideal value. Now 8 you understood, but I assume that this 7 will be the last value, then only that 8 can come. 6 will be the last value, then only that 8 can come. 3 will be the last value, then only that 8 can come. But what is the proof that 2 can be the last value, so that answer 7 can come. I made 0 in the start, right? Then how come the 7 is possible? I'll show you that. Now, what is this? 0, 1, 4, 5, 2, 3, 6, 7. What did I say? For 2, this is, with this we computed every maximum. This will be the final answer. We don't have to rotate it. Why? See, if I put 2 at the start, 2 at the last, it will be what? 7, 6, 3, right? So 0 to 2, I know the maximum. 0 to 5, I know the maximum of 7. Plus 2's maximum means every number, it will be 8. And what is the interesting thing is 367, right? It is not computed here. 367, the maximum will be 0. So 0 plus 7 plus 8. That's how you got this 7 and this 8. Let's try for one more example, right? Let's go for this 5 maybe. 0, 1, 4, 5. 5 is at last. 7, 6, 3, 2 will be at the first. As I told earlier, we already computed for 5 keeping 0 at start. So all this will be 0. 0. Every number will have an 8. So that is 8. And 0, 1, 4. What is the maximum you got? That is 5. So 0, 1, you already computed for 1. You already computed for 4. That's how you are getting it. So if I arrange this in the sense of 0, 1, 4, 5, 3, 5, 2, 3, 6, 7, I get the individual maximum. I get the best possible result before me. And ideally speaking, we are rotating that array also. Same thing. So if you understood it, you can jump to the code part, but I'll take one more example and so that it will be more clear. Now 0, 5, 4, 3, 2, 1, right? So 0, 5, 4, 3, 2, 1. We initially told that before 0, the maximum will be 0 only. Maximum of 5 is how much? It is for this number only. Till 0, it will be 5. If we consider 0, 5 array, if I take 0 only in the subsequence, 5 is the minimum possible number. So you put 5 plus maximum of 0. It is what? 5. Now, maximum of 4 is how much? It is 4 plus, this is here, 4, it's a greater number. So 4 can come here, and also this is the next smallest number. So the first occurrence of smallest also we need to take care. That is what? Here also 4 can come. So it is 8. Now, why did this 8 come? Is like 5 is there. You just pop out from the stack because 4 has the ability to tell anyone before 5, right? Anyone before 5, 4 can come. Before only 5 was there, but 4 is again a possible candidate. That's why. So ideally stating that if 0, 5, 4 is the array, for 0, what is the max of this 4? 0, 5, 0, 5. If I take, what is the maximum? It is 4. So that's how you got 4 plus 4, 8. Now, what is the next number? Maximum of 3. 3 is again greater, right? Now what do I do? 3 plus 3 plus 3. It is 9. Right? Now, maximum of 2. Same thing. 4 2s are how much? 8. Again, maximum of 1. 1 is how much? How many numbers are there in 1 is 5, right? So that is 1, 2, 3, 4, 5. So that is 5. Now what did I tell earlier? If a number is at the last, every number we assume it to be at the last only. We just have to add one more number, that is plus 6. 6 numbers are there. If I consider entirely, it will be 6. I'm just considering the before. So 8 plus 6, 9 plus 6, 8 plus 6 and 5 plus 6. Here if you see 9 plus 6 give me the final answer, that is 15. So max of 3 means what? It is nothing but 0, 5, 4, 3, 2, 1 means 0, 5, 3. This 3 is at last and 1, 2 is at the start. 2, 1, 0, 5, 3 we got, right? This 2, 1, 0, 5, 3 you might be familiar with somewhere, right? That's where this max came. 2, 1, 0, 5, 4, 3. So that is the proof of this. So logically or hypothetically, we are starting from 0, but in maximum of that number means it is statically at the last. That's all. Now let's try to understand this with the help of the code. So we will see the same number, that is here we wrote, right? 0, 1, 4, 5, 2, 3, 6, 7. So we can write like 0, 1, 4, 5, 0, 1, 4, 5, 2, 3, 6, 7. Okay, so what happens? Initially they gave us 2, 3, 6, 7, 0, 4, 5. 2, 2, 3, 6, 7, 0, 4, 5. I told that I need to make it in the 0 index. So I keep track of my zeros index. 0, 1, 2, 3, 4. Fourth index is what 0 is all about. Now this function makes sure I am rotating that array so that 0 comes at first. So 0 comes at first. You can just compute it, right? I plus zeros of index. So 4 plus 1, that is 5 mod, like that index you are coming. So 0 comes here, and here 1 comes. I missed it. 1, 4, 5. Then again what happens? 2, 3, 6, 7. So this is actually rotating the array. So if you compute it with pen and paper, you will definitely get this. Okay, you are just cycling it. Now as I told earlier, we are just putting 0 and 0 as the first number. Then until I find a number that is greater than myself in the stack, if a number comes that is greater than the number in the stack, I say that the greater number does not have the potential to be a max value before that. This number will become the max value. So we'll just compute for few numbers so that it will be trivial. What do I say? You say that 0, 0 came. Now 1 came. Is 1 is less than this, right? So 0 is greater than 1? No. So you put 1 and 1. Now 0, 1, 2, 3, 4, 5, 6, 7. Index again 2, 4 came. 4, 2. Here 4 is also less than 1? No. 5, 3. Fine. And also we compute for one more value, that is 2 and 4. Here things get spiced up. So 2 is a rotated value. Top dot first is what? It is 5. So I just pop this value out of the stack. You pop this value out of the stack. Now again compare with 4 is greater than 2. Pop this value out of the stack. Okay. Now 2 is compared with 1. In this case what happens? You compare the 4 value and the 1. This represents the index, this represents the element. So I say that I have 3 numbers where I can be a max value. So rotated of I, that is 2 into. Earlier for 4, 5 also we need to compute all of this. So I am just telling for 3. 2 into I minus std dot top. 4 minus 1, that is what? 3. Plus max sum of std top of first, that is max sum of 1, which I already computed earlier. Because for 0, 2 cannot be a value, right? For 1, I already computed for 0. Because 1 is a smaller value, and whoever any numbers less than 1 comes, 1 will be the value. So till 2 to 1, 2 will be the max value of all of this. So 2 have the potential to be in 3 places here. After that you just have to do whether this number is a maximum or not. Then after this is done, whatever be it, you just push that number so that the future guys can come and see what is happening. So similarly, like let's say for 2, 4 gets, right? Now let's go for 3, 5. If 3, 5 comes, it's not satisfied. Now what happens? It will be what? 3 into that 2's value also I need to get, right? 0, 1, 2, everything comes. 4, 5, everyone comes. 3 is a value for that. So 5 minus 4, that is what? 1 plus max sum of 2. So 3 plus max sum of 2 will give you 1 value. You just get the maximum value out of this. And ideally speaking, after that you will get a result. You simply add n for it. Why are we adding n? See, 3 means you are computing only this 3. So if you compute everything together, it will be the sum of, it will be the value n. So since n is static across everything, you don't have to add every time. So that's it. So what did we do? Let's just think and try to recollect what all we did. We understood what is a max, we understood what is a permutation, we understood what is a cycle. So for each of the permutation cycle, I can have different max values. If I find for all the combinations, time limit will get exceeded. So I assume that I took an example from the code in the test case, and I saw that every number is here. I assume that if 0 comes on the last, every number will be 0. So that is not an ideal approach. So if 0 comes first, there are chances that it can come. But on the first test case itself, I understood that 0 is not the ideal start value. 2 also, any number can come here. If we take 0, as we saw earlier, right? Like this 1, 1, 1 can come. But if we does not include 0, this can come. So we need a standardized approach. N-square algorithm won't work. So we try to write down all the possible combinations, and we fixed 0 at the start. Why did we fix 0 at the start is because any number that comes at the end, I can easily compute it with 0, because every number that is less than 0 will be there. So that's why if 2 is here means if 3, 6, 7 comes also, every number will be 0. If 5 is here means whatever number comes, everything will be 0. So I find out that 0, if I'm computing the max value of 0, 1 means, or 0, 1, 4 means what? Whatever number, if clockwise 5, 2, 3, 6, 7, every number will be 0. That's why I'm safe to compute 0, 1, 4. If I find the max value of 0, 1, 4, then I can definitely say that 5, 2, 3, 6, 7 is already 0. I don't have to care about it. So if I want to consider a max value of a number, I observed that any number that is before me, any number is greater, that cannot be an ideal max value. So I just keep popping out until I find a value that is less than the current element. Then take that max value and add it. It is like a dynamic programming. Already I remember the answer and then compute it. You just keep doing it. Once you do it, you get a higher number. That number plus the n value. So if I'm getting 2 here, I'm simply stating that 0 to 5 I'm computing it. For 2, it will be a static value. If 2 is at the last, it will be a static value only. So that's all. Like we got this here. We computed for the question, right? 0, 5, 4, 3, 2, 1. We assume 0 is the start. We computed for everything. We got that 3 is having the higher value. 3 getting higher value means what? Ideally speaking, 0, 5, 3. Rest all we did not take. We are assuming that 2, 1 will be on the left side. So all of these numbers will be 0. Once this is done, you just want to add the third number, the 2105 sum of all the maxes plus 8. Sorry, 1, 2, 3, 4, 5. So plus 5 or 6, like how much ever be the number of elements. So here 0 to n minus 1 is there. I just bring the number of elements. So that's all about it. So you get the code in this link. So that's it, guys. So let me know in the comments what do you feel about the video. And if you like the video, right, please do share your comments. That only makes me motivated to more. And if you have any doubts, you can also use that comments to share it. And if you have any other approach also, you can please share it so that we all learn together. That's it, guys. Thank you so much. See you in the next video.